Dear students, this is part 2 of our reactions of alcohols involving cleavage of carbon-oxygen bond. In our previous lecture, we discussed one such type of reaction when alcohols they react with halogen acids, and the order of reactivity of alcohols was tertiary alcohols they were more reactive than secondary alcohols, and secondary alcohols they were more reactive than primary alcohols. So today we will do some more reactions in which this carbon oxygen bond it gets cleaved. So this reaction involves a reaction with phosphorus halides and thionyl chloride. So let us do first reaction of alcohols with phosphorus trichloride or phosphorus trihalide. So I will do the reaction with the PCl3. The same mechanism holds good for PbR3 and Pi3. So let us do this alcohol. First I will write the chemical reaction. What is the chemical reaction if it reacts with PCl3? Now 3 moles of alcohols are used per mole of PCl3, so you get 3RCl plus H3PO3. So if we use PbR3, then you will get RBr. So that's how. Similarly, if you use Pi3, you will get Ri. So this is the reaction when PCl3 reacts with ROH, and in this reaction there is a cleavage of carbon oxygen bond. Now let us try to do its mechanism. So the first step of this mechanism, it includes the reaction of alcohol ROH plus PCl3. So the first step is the reaction of alcohol with phosphorus trichloride. So the reaction takes place like this, and this Cl negative will be removed. So you get ROH positive PCl. Now this is a very good leaving group. Now this becomes a good leaving group. This is very good leaving group. So in the next step, what happens? This Cl negative, it attacks this ROH positive PCl. In this way, this Cl it goes here, so it goes here. So you get RCl, this alkyl halide, plus HOPCl, HOPCl2. Now this HOPCl2, it can further react with this another molecule of ROH. So let us try to write that reaction. So similarly, we can write ROH plus P. We will write it as OHCl. Now this will attack here, so this will go here. So minus Cl negative, what you get is ROH positive POHCl. Now in the next step, this ROH positive POHCl, it gets attacked by your Cl negative. It attacks here, so it goes here. So what you get is RCl plus OHCl. Now this molecule, it can further react with one more molecule of alcohol. In the same way, this Cl will also be replaced by OH group. So you get 3 RCl. So 1, 2, 1 when this react with this alcohol. In the same way, in these same steps, you get third RCl and you get 3 RCls and H3PO3. This Cl will be replaced by OH. So that is the mechanism when these alcohols they react with phosphorus trichlorides to give you alkyl halides plus H3PO3. Similarly, alcohols they can react with PCl5 also. First let us try to write the chemical equation, then we will write the mechanism. So alcohols plus PCl5, the reaction goes like this: RCl plus HCl plus POCl3. So these are the products that are formed during this reaction. Now let us try to write the mechanism. The first step is autoionization of PCl5. So PCl5, it upon its autoionization, it gives you PCl4 positive plus PCl6 negative. So the alcohol, they react with PCl4 positive. Now let us write that step here. So R O H plus P Cl 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 positive. So this alcohol will attack here. So what you will get is R O H positive P Cl 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 Cl. Now this species that is formed, it gets attacked by Cl negative from this PCl6 negative in the next step, and this is a very good leaving group. So let us write in next step. What happen is that this PCl5Cl, so we can write it as Cl negative because we have to give Cl negative plus ROH positive P Cl 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 Cl. This Cl negative with its electrons, it attacks here. So this bonds, it gets broken because it is a good leaving group. So what you get here is that we get RCl alkyl halide plus PCl5 remains as it is. This is minus PCl5. From this PCl5 will go as it is. So plus HO HOP Cl Cl here Cl and Cl. Now we have to produce HCl and POCl, through that are produced from this like this goes here H positive, and this Cl, it goes here. So from this you get HCl plus what is remaining POCl3. So that is how you get all these products, RCl plus HCl plus POCl3. Now as I say, the chemical reaction is quite important. First you should know what is the chemical equation, then according to this chemical equation we will write the mechanism, and we should be able to show the formation of all of these products during the mechanism. So this is the mechanism, how alcohols they react with the PCl5. Similar to this, we have another chlorinating reagent. This is called thionyl chloride SOCl2, and the reaction of alcohols with SOCl2, it is RCl plus SO2, which is a gas, plus HCl, which is also a gas. So this process is called a Darson's process, and the advantage of this process relative to previous processes, that as SO2 and HCl are both gases, so they can be boiled off very easily and we get pure alkyl halide. So pure alkyl halide is formed by removing these gases SO2 and HCl, which are formed in the reaction, and it is very easy to remove these gases. You just have to boil these off. So that is the advantage of this process, that alkyl halide that is formed, it is quite pure. So we need not to do any other purification step. In other reactions, instead of RCl, other products are also produced, so we had to purify this alkyl halide. Now let us try it, and this reaction generally takes place in the presence of a base pyridine. So why we require a base pyridine, I will discuss it with you. First let us try to write its mechanism, then we will able to know why pyridine is required in this reaction. So the mechanism is quite easy. ROH plus SOCl2, it can be written like this. First step is similar to those reactions, so it goes here. So this ROH positive SCl ClO negative. In the next step, this H positive will be removed, minus H positive, so you get ROS ClO negative Cl. In the next step, this Cl negative will be removed like this, so you get R O S Cl double bond O minus Cl negative. This is called alkyl chlorosulfite. Its name is alkyl chlorosulfite. So that is the name of this product, alkyl chlorosulfite. So during this formation of alkyl chlorosulfide, this HCl is produced. Now let us see what is the next step. Now this Cl negative, it attacks here. So Cl negative plus ROS Cl double bond O, it attacks here, it goes here, this Cl is removed. So because we have to produce SO2 also in this reaction, so RCl plus SO2 plus Cl negative. So this Cl negative and H positive, they combine to give you HCl. So these are the products, RCl plus SO2 plus Cl negative. Now let us discuss the function of pyridine, which is a base. Pyridine is a compound of, the structure of pyridine is this. This is pyridine C5H5N, and it acts as a base. The first function of this pyridine is it reacts with HCl, which is an acid, so they form a salt. So this HCl is removed, so that facilitates the formation of this alkyl chlorosulfide, because it takes place through the formation of HCl. So the first function of this pyridine is it facilitates the formation of alkyl chlorosulfide by reacting with HCl produced. Next step is, from this you can see we have to eliminate this Cl negative. This also is quite helpful in eliminating this Cl from this alkyl chlorosulfide. Let us see how. Now C5H5N plus RO S double bond O Cl. So this attacks here, this is removed, minus Cl negative. So we get ROS double bond O, this NC5H5 positive. Now as you can see, this pyridine is helping to remove this Cl negative. In the next step, this Cl negative, it attacks here, it goes here, and this pyridine is removed. You get RCl plus SO2 plus C5H5N. So it remains unutilized. So this pyridine, it helps in the removal of the Cl negative, which is required for the formation of our products like RCl plus SO2 plus C5H5N, and this reaction is called the Darzan's process. It is quite important process because this SO2 and HCl being gases, they can be evolved very quickly and we get pure alkyl halides. So thank you very much. That was all for today. We discussed a reaction of alcohols in which this COH bond is cleaved. We actually did it in two parts. In first part we discussed reaction with alkyl HX. In second part we discussed reaction between PCl5, PCl3 and SOCl2. All these reactions, they involve cleavage of carbon oxygen bond. In our next lecture we will discuss a very important topic, dehydration of alcohols, which involve both alkyl part, R part, as well as this OH part. So these are very important reaction and the products are alkenes. We will discuss them in detail in our next lecture. So thank you very much. Please don't forget to subscribe and share with your friends.